Hello, everyone. Thank you for joining us today at this meetup, this Madrigal meetup. It's my pleasure to have here with us to Graeme Rocher. Hello, Graeme.
Hello.
So I'm going to introduce first the meetup in just a few minutes, and then I will give Graeme the screen to do the presentation. If you have any questions during the talk, please use the public chat. So I will read all the questions after the talk so Graeme can answer them. So we are the Groovy user group here in Madrid, in Spain. We talk pretty much about Groovy and anything related to the Groovy ecosystem. We've been talking about Rails, Gradle, Groovy itself, Micronaut. We've been doing this for a lot of years, probably now more than 10 years now. And we've been recording all our talks. So we have now like 8 or 9 years of recorded talks in our channel. All of them, or pretty much all of them, are in Spanish. So if you know Spanish, go to our YouTube channel, or if you want to improve your Spanish, go there. So that's our URL, madrigal.com, our Twitter, and my Twitter handler. So if you have any questions, if you want to present in the group or anything, just reach out to me. We also have an open collective because this is a non-profit group, so we don't have any money. We don't make any money with this. It's just we do a few of us in our free time. But we need just a few money basically for the meetup, for the domain, for just a few things like that. So if you want to contribute to the group, just go to that opencollective.com/madrigal URL and donate if you want or if you can. And then we have a few sponsors. So Adaptavis, it's paying now for the meetup, and we are using their Zoom platform for doing this talk. B2Boost is a company. It does a lot of Rails and Micronaut work, and they sponsor in our open collective all the months. JetBrains, we will raffle JetBrain license at the end of the talk. If you sign up on the meetup, please stay after the talk for the raffle. OCI is paying for our drinks, or used to pay for our drinks after the meetups when we do meetups physical, not virtual. And Grids pays for the screen capture that we use for recording our so basically that's all. Now, Graeme, you can share your screen and start with the talk. Thank you.
Buenas tardes a todos. I hope you can all see my screen.
Yeah.
I haven't had a great deal of time to prepare this talk, so I hope that I am able to meet expectations with the presentation. I'm going to give you a bit of an overview of what's new in Micronaut 2, and it's going to be mainly demo-driven, and then we'll have some time for Q&A at the end, as Ivan said. So those of you who don't know me, my name is Graeme Rocher. I created a couple of relatively well-known frameworks in Grails and Micronauts. I'm a Java champion, Oracle Groundbreaker Award winner, and just recently became an architect at Oracle Labs. I'm working for Oracle now, leading their contributions to Micronaut. Questions about that, welcome at the end. On the agenda for today, overview of Micronaut 2 and lots of demos, and then Q&A. That's how this thing will flow. So Micronaut 2 came out very recently, just over a week ago. It was 6 months in the making, and it was really a significant improvement in all areas to Micronaut 1.x. And with that, let's take a look at what is really going on in Micronaut 2 and what's the big deal of Micronaut 1. So the first thing I want to talk about is Micronaut launch, so you can go to launch.micronaut.io, or start.micronaut.io works as well. And when you go there, you'll see that we have a brand new application generator for getting started with Micronaut 2, which I think is a lot of people asking for, and is a pretty big deal. So I think there's some interesting features of the generator that I wanted to point out for those of you not familiar with it already. One is you can select a particular application type. So we currently support generating applications that are, traditional REST application, a CLI application, serverless functions, gRPC applications, and messaging applications. The reason we split this out was because that, the project structure, both for a Maven and a Gradle project, is very different for each of these different types. And other areas of interest from, in terms of this group, you'll see that there's a Groovy option, and of course there is a Spock option for getting started with Groovy and Spock in Micronaut. And of course, along with that, you've got Kotlin and Java and all the rest. You can also choose between Maven and Gradle. So let's go back to Groovy and Spock. The other thing you can do is add additional features with this button. So I can come in here, and this is the list of features that we can add to the application to get going. So for example, it's quite common to want to do Micronaut data with JDBC. You can add that to the additional features. And with that done, you can also click this diff button, which is pretty cool, I think. And that will actually show you the difference, the difference that essentially is made when I added the data JDBC feature. So you can see that when I added the data JDBC feature, it added an additional processor and set up a high carrier connection pool and data JDBC and H2 by default. And also in my application configuration, it added some additional configuration to my application.yaml file. So that's pretty cool that you can see the changes. We can also use this preview button to have a look at what my application is going to generate. So in the case of Groovy, we get an application.groovy file, and we get out of the box a Spock specification that tests that my application is up and running, just as a kind of basic get up and going scenario. So this is, and you can navigate in and check what our build.gradle looks like and all sorts of things. So Micronaut launch is really nice, and a really nice addition to the Micronaut ecosystem. It's far more, it's got a lot of options and configuration options. I recommend you have a go and play with it. The other cool thing about Micronaut launch is that it is usable as an API. So what you can do, from curl, go away. What you can do is say curl HTTPS launch IO, like that. And when you do that, it will essentially, it should do that. Is my internet down or something? Well, for some reason when I curl, it's not doing what I'm expecting it to be doing. But basically what you can do is you can say curl demo.zip, and you can actually, create an application like that directly from curl without having to have the Micronaut command line installed. So that added a demo application, and I can say demo.zip unzip directory and cd into that, and just run the app, and I have a Micronaut application that is ready to go. So that's pretty cool that you can like create apps and so forth without actually having to install Micronaut's command line. I can also kind of customize the features I want. So if I can, using the features query parameter, I can say features equals data JDBC, and this value is essentially going to be the same as like what I entered in here. So this UI is actually all in React, written in React and JavaScript, and it's talking to a backend that is running on Google Cloud Run as a serverless application that is actually in Gradle native image and everything. So it's a very interesting project. So I can add additional features, you know, and so forth, and customize. I can also say and lang equals Groovy if I wanted Groovy, and test equals Spock if I wanted to use the Spock framework and so forth. So it's nice that we can actually create apps, and maybe there's some automation possibilities with this as well, etc. And that will essentially give me a new app. So let's get rid of that for the moment. So that's Micronaut Launch, and I think that Micronaut Launch is one of the coolest projects now in the Micronaut ecosystem. You can go and check the source code out at Micronaut project/Micronaut Starter. We actually, it's still called Micronaut Starter. We had a last-minute rename situation, but essentially the source code is in this project, and it's very interesting project to have a look at because it has a build which builds essentially the same application into a native Windows CLI, a native Linux CLI, a native OS 10 CLI, as well as native Lambdas and a regular Netty applications. So we really we have really put a lot of effort into demonstrating as well in this project how you can use Micronaut and Gradle VM native image to build a variety of different kinds of applications, from CLIs to backend serverless applications. And it's worth having a look as well at the API docs. Down here, I can click on the Swagger API, and this will take me to the actual API that I was playing with via curl in here. So, you know, there's a lot more endpoints that you can play with to essentially see what kind of application types there are and so forth. And we can try out the backend API and interact with Micronaut's project generation over the web, which is pretty cool. So Micronaut Launch is a big part of Micronaut 2 and probably like the headline feature, I guess you would say. And you know, when I talk about the CLI, the command line interface from Micronaut, they're really one and the same thing. So we have, from the same code base, we're building a command line interface and also the web UI, both powered by Gradle VM and native image, which is pretty cool. So in terms of the CLI, you know, if you're familiar with Micronaut 1, we have this MN CLI, which you can install by SDK man. So you can say SDK install Micronaut, and we'll set it up. With it, it's essentially doing the same thing as Micronaut Launch, but the cool thing is that you can use it offline. So if we ever one day get to fly on airplanes again, you can you know, create Micronaut apps offline, which is quite cool. And so and it's interactive. So, you know, you can say, I can say mn create app demo, and it'll create my app like that. But you can also just type mn and hit enter, and you drop into interactive mode, and I can say create app demo, and then I can say I want to use Groovy Groovy, and I want to use Spock, and I want to include features, data, JDBC, and whatever else. There's probably a bunch of other things we can do in here. And hit enter, and it'll create my app. And notice how quick as well it executes. So that's because, you know, the previous version of Micronaut 1, the command line interface was in Java, and this one is computed into a native binary image. And we actually worked with the SDK man folks to allow publishing of GraalVM native images to SDK man, so that we can distribute different versions for OS 10 and Linux and Windows and so forth. And of course, you still get all of the project generation and source code generation. So I can cd in here and say mn create controller foo, and you know that'll generate me a controller and a test. You can also do things like mn create bean bar, and if we look at the generated source code in here, oops, I'm just going to close that. Lots of things going on in here. You'll see that you've got essentially the generated project and tests, which will help you get going, so that you don't have to create those manually, and they're all generating Spock and so forth, and you can immediately run those. In this case, I'm using Gradle, and of course, we are able to directly run those. And another thing that we did was, we added support for Gradle W/T, which is continuous mode, so that you can essentially run Micronaut in a kind of continuous build mode. So I can come in here and make a change to this class, and it will automatically recompile and rerun the application, which a lot of folks like to have that experience of automatic restarts and so forth. So Micronaut will do that now, and which is pretty nice. So the CLI is definitely a lot better in Micronaut 2, being native and being much faster and more efficient. So next on the list of cool new things in Micronaut 2 is Maven support, because we really do love Maven as well. And the Maven support in Micronaut 2 is a lot better. So I think we've always had a focus on Gradle for a lot of reasons, but we've definitely improved our Maven support. So one of the things, if I do mn create app and then Maven demo, I choose build Maven, and now we have this new mn run command, which you can use to essentially run a Micronaut project via Maven, and like the Gradle support, if I do mn run and run my application, and then I make a, damn it, I should have chosen Groovy. Writing system out print line in Java is a lot more challenging. Hello. So if I make a change somewhere in my application and save that, you get automatic, recompilation and restarts for Maven as well, which, and Micronaut really does start so fast that the actual changes, by the time you've actually made the change and switched to your browser, it's already going to be up and running. So, startup time, and that's another important thing to point out about Micronaut 2 is, we've already improved performance, which I'll talk about more in a bit. But essentially, as you can see, the server actually is starting up in 542 milliseconds, which is crazy fast. And in addition to that, we have improvements to, so we have the Maven plugin, which allows you to do mn run. We also have improvements in that we've now defined a parent POM. So your Maven projects can inherit from Micronaut parent. And what it does is it just configures a lot of like, and actually we're improving this again, thanks to contributions from the community in the next version of Micronaut 2.0.1. But there's a lot less stuff in here in our POM. It's a lot cleaner because we're using dependency management and plugin management in the parent POM and configuring everything for you. So in general, Maven support in Micronaut 2 is a lot better. So the next on the list is Gradle's awesomeness and Gradle 6.5. So we upgraded Micronaut 2 to Gradle 6.5. So if I do a Gradle demo, the amazing thing with Gradle 6.5 and Micronaut 2 is that we now have incremental annotation processing support. So, and that works really well in, looks like IDEA is not happy. That works really well in IDEA. So, so what you can do essentially is, I'm just going to open my project here. I normally have IDEA set up too. So that's Madrid Gug, demo Gradle. Okay. Okay, open as a project. So, and the reason why incremental compilation support is so important is that it means that essentially Micronaut doesn't have to run the annotation processes on each build. So you'll see in the Gradle build over here, we have this setup configuration for the Java compilation, where we're enabling incremental compilation and doing various things. And the net result of this is that when I run a test, for example, or I run anything with Micronaut, if I make a change to a class that is, so let's, for example, create some controller, for example, control 2, refresh that. So what you'll see is if I make a small change, like here, for example, to this controller method to just alter the return type, you'll see that Micronaut only recreates the bean for a foo controller. It doesn't, recreate any other beans, or doesn't recompile. And if I were to add a change here, test. If I were to add a change here, it's only doing a partial recompilation. And this incremental compilation support in general makes Micronaut significantly faster when compiling and running tests. It's actually quite remarkable that I'm essentially recompiling and running tests in here and through Gradle, and through the Gradle build by delegating everything through the Gradle build, and it's really, really, really fast, right? So previously maybe to achieve incremental compilation you have to switch to the IntelliJ compiler, but now with Gradle you get really, really nice incremental compilation support out of the box with Micronaut, thanks to Micronaut 2. So, and that all leads to, things like performance. Micronaut is faster than ever from a performance perspective. You can see, it's faster to compile, it's faster to build, it's really faster to do everything, and it's faster to run as well. So if I, create a new job and I run this, you'll see that, in general, Micronaut, I'm not passing any special flags to the Micronaut runtime. This is just Java/jar, so I'm not using like verify or any kind of special JVM flags. And startup time is 620, 613 milliseconds, and that's while doing a presentation. So startup time is significantly faster. I think we've achieved maybe a 25% improvement in startup time, which is pretty good. And in general, Micronaut has had performance tweaks throughout. We have smaller stack traces. We've improved the instrumentation layer so that it adds less overhead. And we've really done a lot to improve performance from both compilation performance and runtime performance. So the next big feature is HTTP2 support. So you can enable HTTP2 support by opening up your application.yaml and saying micronaut.server.http version, and then choosing 2, and that will essentially enable HTTP2 support in Micronaut on the server. And the other thing you would need to do is, in general, HTTP2 enables implies using the use of HTTPS and TLS. So you would configure SSL in this. You can maybe do a self-signed for development, but in production you would want to configure it to something more appropriate. You want to enable SSL, and then you will have essentially a HTTP2 server. On the client side, what you can do is essentially when you inject a client, like here, you can say that I want a HTTP2 client, and that'll give you an HTTP2 client instead when injecting a low-level client. That same syntax works when you're using a kind of decorative client. So if I had I had a client here, and this was an interface, like so. If this was an interface, we could equally have a client like that, and specify the HTTP2 version, and then inject flu client to get your declarative client. That's using HTTP2 for communication. So that's essentially how HTTP2 is enabled and works. There is still more to do in the area of HTTP2 for Micronaut. So we may want to add future support for pushing files down and so forth. However, the existing static file support and all that kind of business is already, static content support has already been updated and works with HTTP2 push. So that's good. So in terms of what's next on the list, we have support for servlets. So now, in addition to Netty, if you prefer to use a servlet runtime, what you can do is I can say mn create app servlet demo, and I can say features. Well, let's do this interactively. Servlet demo features Jetty server, for example. And there's various, so there's Jetty server, there's Tomcat server, and I believe we have Undertow server. So, whichever one, Jetty is so far in our benchmarking the fastest to start up. So I tend to recommend that. And that'll give you a servlet application, and which you can run just as you would, you know, the Netty version. And as you can see now, I'm using Jetty as my servlet container. Other than that, everything else works the same. We have, of course, servlet environments are more suited to running, you know, potentially blocking operations and the thread per request model. And of course, you know, for folks who have legacy integration, you know, you basically can now include existing servlets and servlet filters. So a lot of folks will be happy to have the ability to write. A lot of people will be happy to have the ability to write, you know, servlet logic in Micronaut, and you still get the same experience of, you know, tests executing super fast, just with the servlet environment. And the other thing that we do support as well is we support Graalvm native image across all the different servlet containers we support. So whether you're using Jetty, or whether you're using Tomcat, or whether you're using Undertow, you can compute the generated runnable Uberjar into a native image. So this guy here can be computed into a native image easily. And yeah, that all works as you would expect. So another major theme in Micronaut 2 is serverless support. We have significantly improved our support for serverless in a number of different ways. And actually, this is, you know, kind of something that's probably nicely demoable through Micronaut launch. So we now have two ways where you can define for each serverless provider, AWS, Google Cloud Function, and Azure. You can either define an application, and then you can add, for example, if I add the Cloud Function feature in here, what will end up happening is we will get an application that, you know, is defined in terms of normal controllers and add controller and add get and so forth. And what essentially happens is Micronaut will defines a kind of a handler for that essentially provides routing, or like a gateway to route function requests to your controller. So the advantage of this approach is that you can essentially build a traditional application, not like a normal Micronaut application using app controller and app get and so forth. And then, for example, you can deploy a slice of it that you want to make serverless to Cloud Function or to Azure or to Lambda, and it works as you expect. So the other thing that we do is we automatically set up, for example, the Cloud Function. It'll set up the Cloud Function invoker so that you can run the function locally and test it locally against Google's function SDK. So if I do the same thing and then I switch to, for example, another provider, let's say Azure, you'll see that we do again the same thing. But Azure function only supports JDK 8. Oops. So let's go back to JDK 8. At least Micronaut launch, you know, tells you when something is not compatible with each other. So for Azure, again, you know, it sets up, you know, a typical Hello controller, but then it will also create the function trigger for Azure. So you essentially, this is your trigger, and it will route or route requests to your controller as they come in, as the function invocation happens. And in addition, you know, we set up the Azure function SDK, so you can run your function locally and test it and deploy it with Micronaut. And same thing with AWS. So if you do AWS Lambda, we basically, again, reconfigure your project to ensure that you can define controllers and so forth. But this time using Lambda. So in this case, we integrate with AWS Serverless container, so that allows essentially proxying onto your Lambda, and you can define your application as traditional controllers and so forth. So what happens then when we switch that to the serverless function application type? So what happens when you switch to the serverless application function application type is that essentially you, instead of writing like a normal application, you can write actual low-level functions. For example, I can directly write Google Cloud background functions that subscribe to pub/sub messages and use dependency injection with them. So that's the alternative approach. That when you choose the serverless function option, you essentially get lower level function support. Same thing if I choose, for example, Lambda, you'll see that what you get is, request handlers, which are low level Lambda request handlers that are much, below level, integrate directly with Lambda. So in case of Lambda, if you wanted to like listen to specific Lambda events or payloads, you may want a request handler of this nature. So a lot of work has gone into making our serverless support more robust. And the other thing that I didn't demonstrate as well is, for example, for Lambda, if you also choose the GraalVM native image feature, in addition, it will set up a project for you that is, well, it's not supported for Groovy language, sorry. It'll set up a project that allows you to essentially deploy a native Lambda using GraalVM native image directly to the Lambda environment, so that it gives you a Docker file that lets you build your native image and deploy it into a function.zip file, which you can then deploy to Lambda and so forth. So it'll help. It's worth keeping an eye out, seeing the combination of AWS, Lambda, and GraalVM, because there's significant gains to be had in terms of cold start times with that combination. Okay, so next new feature that we have is Reactor libraries. So we have support for RxJava 3. So if you go to Micronaut projects, so Micronaut RxJava 3, we have a new module which you can add to your class path to enable RxJava 3 support, which has just come out. And that allows you to use RxJava 3 instead of RxJava 2 in your Micronaut application. We also have another module for Reactor, which has now been externalized. And these modules go further than just providing the library integration. So for example, for Reactor and RxJava 3, there are additional modules that expose a Reactor HTTP client if you want to use mono and single and so forth, mono and flux, sorry, APIs in your code, in your HTTP client code, instead of RxJava single and flowable and so forth. So those new libraries, support libraries, and we have support for Reactor, RxJava 3, and RxJava 1, which I've forgotten, which is obviously there for legacy reasons. And finally, I want to mention that we have really improved our support for GraalVM native image. So there's so much more that you can do, and I'm probably not going to start building native images live right now because it's they take a while to build. But just as a summary of what we have with native image is In Micronaut 2, we have native image support out of the box for all of the popular JDBC library drivers. So you can use Postgres, MySQL, Oracle, Microsoft SQL 82, and the driver will automatically be configured for you, and you don't have to worry about things not working or configuring stuff manually on your VM native image. It just works. We have support for numerous additional modules, including Redis, Elasticsearch, and probably more that I'm not remembering. But basically, Kafka support is improved for native image. Oh yes, and also for the entire AWS V2 SDK, we have support for native image. So if you're building Lambdas and you want to use the AWS V2 SDK in Micronaut, those libraries work in your Lambdas, which is really cool. And a lot more third-party libraries are essentially because Micronaut 1.x, if you stuck to just Micronaut libraries, things just worked. But in Micronaut 2, we have essentially improved the support for different third-party libraries, from database drivers to connections to Redis to everything. So that's a big deal. So in summary, all kinds of awesomeness in Micronaut 2, from the Micronaut launch to the command line interface, to the improvements to building with Gradle and Maven, to incremental build, to the runtime being faster. It's easier to get going than ever. It's easier to go native with GraalVM. It's faster than ever. And if you want to find out more about Micronaut 2 and what's new, I recommend, because there are, there's just a summary of the highlights, but there's so much more that I haven't really covered, and lots of little details. I recommend you go to this link here and check it out. And with that, I can leave it to a Q&A session to see what people. If people have any questions, essentially.
Thank you very much, Graeme. So we have a few questions, and if anyone has more questions, please write on the chat and I will read them for Graeme. So one question, any plans for Maven BOM instead of parent POM? Usually enterprises have a corporate parent POM that can be replaced.
We already have a BOM, so we publish a BOM. The parent POM includes the BOM. So we already have a Micronaut BOM. If you can find it on Maven Central. It's called Micronaut BOM. It has all of the dependencies that we know work together with each version of Micronaut. The parent POM is a bit of additional setup and configuration for any kind of plugins and so forth that are used.
Another question. What are the key points to take extra care when upgrading for 1.x to 2.0?
So the biggest one, which I probably brushed over, is we have a new threading model. In Micronaut 1, we tried to implement something that was maybe a little bit too clever, in that you would use the return type of the method to decide whether to shift an operation onto the IO thread pool. And in Micronaut 2, it always executes on the event loop unless you use an annotation called execute on, or you explicitly schedule the operation yourself. So in general, the upgrade task there is if you are using JDBC or Hibernate in your application, which are clearly blocking interactions, you should add execute on task schedulers.io. That's covered in the what's new guide and the upgrade notes.
Yeah, I'd also add that we have renamed a bunch of modules, the group. So for 1.x, it was IO Micronaut.configuration for a lot of modules, and now they have their own groups like IO Micronaut SQL or Redis or Flyway, RabbitMQ. So keep an eye on that if you are using any of those dependencies. But
yes,
they are also covered on the what's new and on the upgrade notes.
Yeah, we have a big upgrade documentation which covers like all of these things, so the group ID renaming, the threading model change, and so forth. So we recommend you take a look at that and follow the instructions there before pushing to production.
Yeah. So any more questions? We can wait a few minutes or so if anyone has more questions. And if not, we will stop the recording and I will do the raffle. Yeah, we have a maybe off-topic question. Briefly, what's the aim of the Micronaut Foundation?
So there are a lot of interested parties in Micronaut now. I have recently started working for Oracle, who are going to be making significant investment in Micronaut, and it's going to be easier to help coordinate the future of the framework if there's a foundation in place, and I can represent Oracle's interests, and various other technical leaders can provide input to the direction of the project. That way, decisions are not just made by one company, but they are made by a group of experts in the area. And so the main thrust of that is the technical advisory board, where we'll be meeting once a month or once every couple of months, I believe, to do planning on direction of the framework, and also obviously to the foundation is also there to coordinate contributions from foundation members, for example, and if any kind of specific investment needs to be made by a company, they can do that through the foundation, which is non-profit. So that is the aim of the foundation, to coordinate that effort.
Another question: what do you think about Project Leiden?
So I think that's a very interesting initiative by the Java team at Oracle, and I think that
can you explain in a few sentences what is for anyone?
So Project Leiden is an effort to standardize native images for Java, essentially including them into Java itself. And then, different potential vendors would be able to implement the specification that Leiden defines. So I think that means that, the Java team have taken note of the interest in native image and GraalVM native image in particular, and I think I think the GraalVM team and the Java team will certainly be working closely on making sure that's a well thought out effort. I think it's still early days; it's still much to be worked out, but it will be very nice in the future if native image was directly built into the JDK. And I believe that is the aim of Project Leiden.
Okay, another one. Do you have any information right now which could be the future of Helidon now that you are at Oracle? A mix of Micronaut and Helidon, others options?
So there is some overlap between Micronaut and Helidon around the area of microservices. But in general, Micronaut is much broader than just microservices. Micronaut is you can use Micronaut to create command line applications, serverless applications, messaging applications, and a whole bunch of different areas. So I believe that the teams are complementary, and what we are going to be looking at doing is leveraging more of Helidon is more like a library. Leveraging more of Helidon's libraries in Micronaut. I think that question is actually from Jonathan, who is from Red Hat. So I think that much in the same way the Quarkus team leverages libraries from Vertex, Micronaut can leverage libraries from Helidon. and that will help us avoid unnecessary duplication of effort.
Okay. Any more questions, folks? Okay, I think that was all. So thank you very much, Graeme, for joining us today at this meetup. Thank you all for joining. So let's stop this.
Thank you very much.